track of it when they're in order. Now they're not in order. I don't know when I'll see you again. But when I do, we will have another quiz. And it will have two problems on it. One will be substitution, like you just did. And the other one will be elimination. So I am on my notes. Same place I was last time, the back of page 43. Only now I'm doing the problems that say elimination. Now, when we do elimination, remember, the goal is to eliminate a variable. When we add, if we were to add these together, we would not eliminate anything because that would give us 7x and that would give us negative 2y. So I have to make a modification in the problem so that when I add, something drops out. And I don't care if it's x or y, something drops out. Okay, we are in our notes, the same place we were last time. The back of page 43, we're doing section 7.1. We are in our note sheet. We're not in the chapter 7 worksheets or the practice tests. We are in our notes. Jake, you are not in your notes. You need to find your notes. No, you had them. We used them for chapter 5, Jake. No, I didn't just hand them out. We used them for chapter 5. It's the same note sheet. Jake, it's part of this note sheet that you have. Okay. If you can't find it, then just write down the problems and take a picture of somebody else's. All right, who remembers how we do this? Shelley? So one option would be to multiply the bottom equation by 3. So the top equation stays the same, and the bottom equation we are going to multiply by 3. Now the reason that we would do that is so when we add them together, notice that the y's are eliminated. So now you have a simple little equation that says 17x equals 85. So x equals 5. And at this point then, it becomes just like the substitution problems. We have to plug it back in and figure out what y is. And you can put it in anywhere you want. I'm going to put it in the bottom one. So 5 times 5 plus y equals 24. So it looks like y is negative 1. And then I write my answer as an ordered pair, 5 comma negative 1. So we're doing exactly the same thing you just did on your quiz. You're just doing it a different way. You're figuring out where two lines intersect, and you're doing it by eliminating a variable instead of by substituting it. All right, so let's look at number 4. Do not panic just because these are squares. Things are going to eliminate in exactly the same way. So take a look at it. You've got options. Do whatever's easiest for you, but you have to make it so either these cancel out or these cancel out. So what do you suggest?
Top by negative 2.
Top by negative 2 will work. You may not want to do that. That's up to you, but that certainly is a good option. Do want to remind you that when you multiply the top by negative 2, it's everything all the way across. Everything has to be times by negative 2. So negative 2x squared plus 6y squared equals positive 22. Now, you did that so that this would happen. It's called elimination. You're eliminating a variable. So 7y squareds are 28. So y squared is 4. Now be careful. Y would be, watch it, plus or minus 2. When you square root, you get plus or minus. So we had one of these yesterday. We're going to have two answers. One with a positive 2y value and one negative 2y value. Then you go back, it doesn't matter, either equation. I guess I'll just use the top equation, x squared minus 3y squared equals negative 11. And I'm gonna put in positive 2. Okay? So what happens when I put in positive 2 for my y? I get x squared minus 12 equals negative 11. By the way, what's going to happen when I put in negative 2?
Same thing.
It'll be the same thing, isn't it? Because you're squaring it when you put it in. So x squared equals 1. What does x equal?
Plus minus 1.
Plus or minus 1. So when I put in positive 2, I get plus or minus 1. And when I put in negative 2, I get plus or minus 1. Wait a minute. How many answers does this problem have?
4.
4.
Yes.
Now, geometrically, what's going on? This one that we started with was 2 lines crossing in a point. This equation is what we call a hyperbola. So this equation looks like this. This one is an ellipse, so it looks like this. Do you see how there could be 4 answers? 4 places where they intersect each other. Right? All right, one more, number 5. Now, remember, you're told in number 5 to use elimination.
Multiply by 2
So
on something.
things have to be rearranged here a little bit before we get started. If you're going to use elimination, everything has to be lined up because you're going to be adding, right? So let's clean that up. Move the y over so that things are in columns here, but we can add them. All right, so what do we want to eliminate? So multiply the top by negative 2.
It's gonna cancel both. It's 0.
So we have negative 2x minus 6y, negative 16 on the top,
That's crazy.
and 2x plus 6y equals 16 on the bottom.
So everything out.
On this side, I have a 0. On this side, I have a 0.
Is that all solutions?
That is not all solutions, but it's close. There are infinitely many solutions. Not everything in the whole wide world, but there are infinitely many. Before I talk about how we write that answer, I need you to understand that this is different than what happened last time. What happened last time, I don't remember exactly, but we got something like 8 equals 11, or 0 equals 11, or something like that. If you get a false statement, 8 equals 11, then there is no solution at all. But if you get a true statement, like 0 equals 0, or 6 equals 6, then you're going to have infinitely many solutions. And what that means is, I wrote these as 2 separate equations, but they are actually the same line. If you graphed this one and you graphed this one, they would be right on top of each other.
So could you simplify
Okay.
the equations?
Yeah, so that one would simplify to that one. Yep, they would be exactly the same equation. So we write same line. Our answer is they're the same line. So the points they have in common, every point on the line. Now that's different than what happened last time. Janae?
So if you just write 0 to 0 without the same line, it'd be wrong.
Well, partially wrong, yeah. We need an answer. Just like when we did this one, we wrote our answer as ordered pairs. We need to write an answer here to the
You say
question.
same line, you don't say infinite.
No. Well, there are infinitely many points, but if you're going to say it that way, if that's what you're going to say, then I'm going to insist that you write it the right way, which would be this. That would be the right way to write that answer, if that's how you want to do it. I'm saying write same line and we're good.
Yeah.
All right, so the quiz you take next time we're together will have two problems. One will be a substitution like you just did, and one will be an elimination like we just did here. Keep in mind, you do have homework problems available to you to practice if you would want to spend any time outside of class on this. All right, now we're moving on to 7.2, which is what the main part of this little unit is about. We're going to talk about matrices. So the first part there is vocabulary. So we're going to talk about vocabulary as we talk about part number 1. Okay, so we're going to fill in the vocabulary as we talk about number 1. So A is defined like this, B like this, and C like this. These are matrices. This is a matrix, this is a matrix, that's a matrix. You have 3 examples here in problem number 1. By definition, a matrix is a rectangular, okay, that makes sense to you, right? Rectangle, don't those shapes look like rectangles? So it's a rectangular array. That's kind of a fancy word for arrangement. It's a rectangular array of numbers in rows and columns. Easy definition. It's a rectangle full of columns and rows of numbers. That's what it is. Since it's a rectangle, it has sort of a length and a width. That's called the dimensions of the matrix. The dimensions of the matrix are rows, the number of rows by the number of columns. So in other words, this matrix, A, would be called a 2 by 2. 2 rows. Rows go this way. Think of the rows of a bleacher. The rows of the bleachers. These are the rows. And then you think of the columns of the White House. These are the columns. So this matrix has 2 rows and 2 columns. So we call it 2 by 2. The row number comes first, Roman Catholic. The row number comes first, column number comes second. So when I look at B, how many rows does it have? Rows. Rows are bleachers. Rows go across. How many do you have? 2. How many columns do you have? 3. This is a 2 by 3. And C would be another 2 by 2. Rows go across. Think of the bleachers. Think of the columns of the White House. If you happen to have the same number of rows as columns, then the matrix is called square. Does that make sense to you, that vocabulary? I mean, think about it. If a matrix is a rectangle and its dimensions are the same, isn't that what a square is? So a square matrix has the same number of rows as columns. So it's 2 by 2, 3 by 3, 4 by 4, something like that. A square matrix, same number of rows as columns. So we have done problem A. 1A is done, right? Okay. Now we're going on to 1B. This has to do with some more definitions. When you see the little a, that refers to the entry in the matrix. Sometimes those are called elements. But the entry and the element are simply the numbers inside the matrix. Remember, we said a matrix has a bunch of numbers in it. These guys are called entries or elements. If we're using a little a, like problem B says, a sub 2,1. If we're using a little a, then that immediately means we're talking about the numbers inside matrix A. If we use a little b, we're talking about the numbers inside matrix B. It's like a secret code. Okay? Now, when we see this 2,1, okay, I know I'm looking at the numbers inside the matrix. The 2,1 tells me which number to look at. In matrix land, Roman Catholic, R comes first. So I'm looking at the second row, rows of bleachers, the second row of bleachers, and the first column. So in matrix A, the second row and the first column, that number is a 3. A sub 2,1, go to matrix A, row 2, column 1. So B sub 1, 2 would be, all right, so we look at matrix B, first row, second column. So matrix B, first row, second column would be that 0 right there. So that's what that is. C sub 3,1. That means go to matrix C.
They don't have 3 rows.
Trick question. This board's getting wild and wacky. There is not a third row in matrix C, so there is no entry in the 3,1 spot. You don't have a third row. Okay? The word scalar is a fancy word for real number or coefficient. The language of matrices and vectors is different. They have a whole bunch of different vocabulary words. I'm not sure why. But the word scalar simply refers to a number. So if somebody said, like, I hate to do this, but let's jump down to problem E. Problem E says 2A. 2 is the scalar. A is the matrix. So this tells me to take 2, the number 2, times matrix A. Well, that's easy. What do you think that would be? What do you think that answer would be if we took 2 times matrix A? 2, 4, 6, negative 8. That's exactly right. When you multiply a matrix by a scalar, when you multiply a matrix by a coefficient, you just take that number times everything. And that's it. Easy. One more definition. You should have all your definitions filled in except the last one. Equal matrices. If matrices are equal,
Same number of rows as columns.
there are 2 parts to that. In order to be equal, they have to have the same dimensions. Now, does that make sense to you? That if 2 matrices are going to be equal, if the first one's a 2 by 3, the second one would have to be a 2 by 3? Yeah, if they're going to be equal, they have to be the same size. Okay? The other thing that has to happen is they have to have the same corresponding entries. Now, this word is very important. Here's why. I could have 2 matrices. These guys have the same dimensions, right? They also have the same entries. Same numbers are in there. but they're not equal. Because why? They're not in the right spot. They're not corresponding. And by corresponding, I mean this one has to be the same as that one. So these would not be equal matrices. If you leave this word out, you're wrong. So make sure you highlight that word, corresponding. To be equal, you have to have the same dimensions, same size, and you have to have the same numbers in the same places, the same corresponding entries. We good on definition? This test will have a definition section where you have to write in some definitions. So here they are, the ones you need to know. Okay? All right, so we've done A and B. We're ready for part C, problem C. Anybody want to take a wild guess about A plus B? I'll give you a hint. You can't do it. You can't add A and B. Does anybody have a guess as to why A and B can't be added? David?
Different number of columns.
Yeah, they're not the same size. If you're going to add matrices, they can be any size you want them to be, but they have to match. So you could have a 4x7. But in order to add it, you have to be adding it to another 4x7. If they are not the same size, you can't add them. Move on. How about D? Can we add A and C? Now, how do you think we're going to add matrix A and matrix C? Zach?
I'm just gonna guess, like, you have like the numbers of the corresponding points.
That's it exactly. So this spot would be 0. This spot, 3. This spot, 7. There you go. Oh my gosh. How do you add matrices? You do exactly what Zach just said. First of all, you make sure they're the same size. And second of all, then you add the same numbers in the same spots. Period. It's that easy. Right? We're not going to screw this up. All right, we did E. All right, F. Now we got a couple of things going on. F. 2C minus A. Now the first thing you need to do is take care of this. Okay? So what is 2 times C?
-2,
80. Did I do that right? I can't see that number down there.
Yeah.
2280. Okay? Now I'm going to subtract A. Now, the rules for subtraction are the same as addition. You have to be the same size. These are the same size, so I can subtract them. Okay? So here we go. What do you think the answer is going to be? -2 minus 1. -3. 2 minus 2. 8 minus 3. 0 minus -4. There's your answer.
Minus negative, yeah.
0 minus -4.
Yep.
Remember, you're subtracting. Okay, how about B minus 2A? Can't do it. Can't do it. Don't waste your time even messing with it, folks. Why can't I do B minus 2A? They're not the same size. You can't add or subtract if they are not the same size. Okay? No adding or subtracting if they're not the same size. Okay? So far, so good? All right, so then we're turning the page over. Now I got new matrices. And this is where things get a little bit exciting. Because notice what I am doing in problem A is multiplying a matrix times another matrix. Okay? So I am going to multiply matrix A, which is this, times matrix F, which is this. Everybody okay with that? All right, now, I need you to listen to me. When we add and subtract matrices, the rule is very simple. If you're going to add and subtract them, they have to be the same size. That's the rule for add and subtract. I am now multiplying. So here is the rule for multiplication. Write down the dimensions of this first matrix. Okay, so how many rows, how many columns? This is a 2 by 2. All right, now this is our first example. It's going to be easy. Hang in there, listen to what I'm saying, write it down, because it's going to get a little harder. What are the dimensions of this matrix?
2 by 2.
That's also a 2 by 2. In matrix multiplication, the rule is these two have to match. If you are going to multiply matrices, the inside dimensions have to match. So if I gave you a 5 by 7 and a 7 by 6, you can multiply them. You can't add them, but you can multiply them. As long as these two match, the matrices are multipliable. Okay? That means if you had a 2 by 3 and another 2 by 3, while you could add them, you cannot multiply them. Okay? So step 1 in matrix multiplication, make sure these match. Step 2, your answer is going to be this size. So my answer is going to be another 2 by 2. Up here in this example, my answer would be a 5 by 6. This one has no solution. So the two inside dimensions have to match. The two outside dimensions tell you how big your answer is. All right? Now, I know that my answer is going to have 2 rows and 2 columns. 2 rows and 2 columns. Right? I know that this number right here, whatever it is in the first row, first column position. Right? First row, first column. To get that answer, then, I am going to multiply the first row times the first column. You'll get this. So here's how I want you to do it. I want you to write down over to the side. This is going to take some space. Some of you will, after we practice, will be able to do it in your head, but it's going to take a little space to get started. I want you to write down the first row. There's the first row. In the first matrix, we always use the rows. In the second matrix, we always use the columns. This number that I'm trying to figure out what goes right here is in the first row, first column. So I'm going to write down that first row of numbers. Right next to these, I'm going to write down the first column of numbers. So here's my first row, and then -1, 3 is my first column. Put a plus sign between them, and that's the number that goes right here. So it's -1 plus 6. So this number will be a 5. I took this number times this number times this number, and added them up. -1 and 6. -1 and 6. Now I'm going to move over here. I Now what is this? Well, this is still the first row, but now it's the second column. So the first row, and now the second column. So first row, second column. So that also works out to be 5. Total coincidence, random. Now we're ready for this spot. Now be careful, where am I now? What's this? Second row, first column. So my second row of numbers are these, 3, -4. And my first column is -1, 3. So what am I going to get for that spot? -3 and -12, -15. So we took this times this times this. And then the last number is the second row, second column. So second row, second column. Again, totally random. That works out to be 15. There's nothing special about that. Please don't think that there's any kind of pattern or anything. There isn't. Just the combination of numbers that I picked. Crazy is right. Lot of room for error in there. You have to kind of go carefully and be organized. Okie dokie. How about FA? Now, FA would be exactly the same two, but in the other order. In real multiplication, we call this the commutative property. In regular multiplication, we can take 2 times 3 and 3 times 2 and it doesn't matter, right? Well, let's see what happens in matrix land. I don't think it's going to be commutative, but let's see. So this one's a 2 by 2 and this one's a 2 by 2. Good news is we can multiply and the answer will be a 2 by 2. Remember, these guys tell me the size of my answer, the dimensions of my answer. And I know we've only done one, but you remember how to get this guy right here? What do? We take the first row, which is -1 and 5, and we multiply it by the first column, which is 1 and 3. So what do we get for that first spot? We get something that we didn't get before. What do we get? 14. So the first spot is 14. Why don't you take a minute and see if you can fill in any of the other ones. See if you can fill in any of the other blanks. First row, second column. See if you can fill any of those in. this one? Anybody get it yet?
-6.
I don't think it's negative 6.
-22.
Negative 22. Remember, to get that spot, you gotta take the first row, Brittany, which is negative 1, 5, times the second column, which is 2, negative 4. The first row of numbers times the first column of numbers. So we get negative 22 for that spot right there.
12 is the next one.
Anybody got this one?
12 or 8?
3.
Oh.
3. Because it is the second row of numbers times the first column of numbers. Second row, first column. So that's how we got 3. And what'd you get on the end?
6.
6. Perfect. That's 6. Because it's the second row times the second column, and that adds up to 6. Alright, we're gonna practice some more. You need to be able to do this. Okay, letter C. D times E. Can you not do it?
Yeah.
You cannot do it. What are the dimensions of D? Is it emergency? What are the dimensions of D? 2 by 2. What are the dimensions of E? 3 by 3. And what's our rule? A 2 by 2 and a 3 by 3 will not multiply because these do not match. So C, problem C, is an empty set.
So the 2 inside numbers just tell you if they multiply.
Yep.
And then the 2 outside just tell you how big it is.
Yep. Yep. All right, D times G.
Nope. Different dimensions.
No.
Yes.
Different dimensions doesn't have anything to do with it.
Wait, what is it?
As long as these two match, Brittany, we can multiply anything.
Oh.
We can't add them, but we can multiply them as long as these two match. So matrix D is a 2 by 2. Matrix G is a 2 by 3.
Can you just like cross out the third column?
So these multiply.
No. So could you just cross out the last?
And the answer will be a 2 by 3. The answer is going to be a 2 by 3. So it's going to have 2 rows of the bleachers and 3 columns. All right, let's see if we can get through this. This is the 1-1 spot, first row, first column. So we're going to take our first row times our first column. So 1, 1 times 1, negative 3. So that spot will be negative 2. Now, what spot is this?
Row
Row 1, column 2. So you're going to multiply row 1 times column 2. Remember, the rows, I circle these to remind myself, the rows come from the first matrix, the columns come from the second one. So row 1, 1, 1, column 2, 2, 1, so that number is going to be a 3.
Yep.
This is the 1, 3 spot. So row 1, column 3. That is also going to be a 3. Everybody good on that? Those numbers? All right, let's see if we do any better with the bottom. Let's try the bottom now on our own. Keep in mind, this is the 2, 1 spot. This is the 2, 2, and this is the 2, 3. So you're multiplying now the second row times first column, second column, third column.
So it's 3 negative.
We'll say it out loud. Let's see if everybody can fill them in. What did we get here? If you got 9, you are right, because it's 3 negative 2 and 1 negative 3. So 3 plus 6 is 9. Perfect. It's row 2, column 1. So the next one, what did you get for the next one? 4. If you got 4, you got it right, because it's row 1, column 2.
The last one's 9.
And the last one is indeed 9, because it's row 2, column 3. 9. Oh, we're not done. What about GE? Can GE be multiplied?
Yeah.
And that's going to be a big one.
Oh, yeah.
So we're going to hang on to that one, and we'll start there next time.
Monday. Wait, did you get a ball?
I haven't had a full week of school at all this semester.
No homework.
So what do you do? No, Hancock,
This is
freaking semester.
What they do? Samuel Adams.
My guess is that we will have,
He has a beer company.
you know, we have a quiz next time over 2 problems, substitution elimination. My guess is we'll have another quiz the next time over matrix operations.
This is a reminder that all sophomores are to report to the atrium with their iPad.
Wait, is it everything?
Wait, nobody leaves. We're not
Can you
dismissed.
use everything that's not the Bill of Rights?
I missed like 3 classes for your last day.
How can you use everything that's not the Bill of Rights?
Yeah.
Damn. The Bill of Rights is so easy, but everything else is like, so, well, the 25th Amendment is the amendment that you can.
What's the Bill of Rights? Is the Bill of Rights the first time?
Yeah, the 25th is where you can remove the president if he's not fit for office. Like,
Samuel Adams did propaganda. Samuel Adams did propaganda.
14th is the one that gave slaves freedom.
Those are how many lines?
There's John Hancock and John Adams.
Not how many numbers.
14th is like the Mexican rights.
You see how many rows of bleachers?
They came over
How
from
many rows are there? No matter how many people are sitting in them, those are
different
rows of
citizens,
bleachers.
foreign citizens. And
And
then
they did the anti-tax.
18 is illegal. Isn't it 18
All
like
right,
legal drinking is 21?
Dylan, would you turn the video off if it's still running?